Write this down, all right? This should be Tuesday after our 3 day weekend. So write this down. Unit 2, day 9, all right? Press pause, copy everything, okay? These two are rectangles. One is smaller in size than the other, okay? So just sketch it out. So press pause right now and sketch it out. So press pause right now. Okay, all right, so for November 12th, all right, so today we're going to spend one last day on proportion word problems before we do unit rate tomorrow. So here I got a new twist for you. Okay, so here's what we've done so far, all right? By the way, I got to tell you, like, this is sometimes the only way I could speak to you while I'm doing this. So I'm looking on my YouTube channel, and I noticed that the first 4 lessons, basically the first week when I was out, the number of views on the video were very low. Like they were basically 8, 9, 10, 11. Like number of total views, and there are 130 of you. So I'm wondering what's going on. So if you can tell me next time I see you, let me know. But the views last week were very good. Like they were like 128, 100, like around that range. So I'm curious what was the difference between last week and the first week when I was out. All right, so let me know. So this week then, right, Tuesday, Wednesday, Thursday, Friday, today we're going to do proportion word problems. Tomorrow, the next 3 days we'll be doing unit rate, okay? So that would constitute the second part of our online shopping. So meaning, last Friday's lesson, right, when we were dealing with money, remember that? It's one way we can go to do online shopping, okay? And tomorrow for unit rate is the second one, all right? Which means you get to go online shopping at Sephora and Fresh Direct and all that, all that good stuff. So okay, all right. So what are we doing here, right? So okay, so when we deal with proportion word problems, sometimes we not only deal with money, like exchanging money from one country to another country's currency. It's also a new kind of problem here that involves geometry. Okay, ready? Okay, so let's say we have 2 rectangles here. They are similar, meaning similar figures. Well, so what are similar shapes, right? So technically speaking, similar shapes are basically if I were to resize a picture. So let's say you're in, I don't know, computer class and you have a project, right? Or let's say you're at home and you're doing a social studies project. And you have to resize a picture because, let's say you don't want to write that many words in your essay and, you're trying to be slick, right? And you're trying to make the picture larger so that it will take up more room so you don't have to write as much, right? So what you would want to do is you don't want to take a picture. I should have put a photograph in here actually. You don't want to take a picture and enlarge it in such a way that like the actual picture would look weird. You know what I'm saying? Like, so if you have like a picture of a celebrity, right, in a smaller photograph, and you make it larger, you don't want them to like get all stretched out, right, and out of shape. So that's what we're talking about here. So, okay, having said that, right? So let's say we have a smaller rectangle here, all right, and it used to be, okay, I'll use a very simple mathematical example. So let's say it used to be 4 by 6, okay, a very, very common dimension for a photograph, right? So let's say our old picture here is 4 to 6, and the new picture now has a width. So in this picture, the length is 6, and let's say the width is 4, right? And in your new picture, let's say, right, the new width is now 8. You want to make this, let's say, 8 inches wide. So the question is, what's the new length here? So do you guys understand the question now? So, okay, well, let's set up a proportion then in that case, right? Because it has to stay, like the picture, think about the word that I'm using. The picture has to literally stay in proportion. So imagine if you take a picture of yourself, right? What do you guys, what do you kids call that? Oh yeah, selfie, right? So if you take a selfie, all right, because back in my day, we don't take selfies. Uh, so, right? Because all you young people, okay, there's a truck behind me. This is crazy. Anyways, I'm just gonna keep going. All right. I live behind a supermarket. Okay, so what was I saying? Yeah. So you know, all you young folks out there, right? When you take a selfie, if the original picture is four by six, as you see here in the red, and you have to resize your picture, you don't want your face to be misrepresented, right? Get all stretched out or like get all like too narrow, right? Meaning the pictures are set to be in proportion. Right? Like your forehead's not gonna be any bigger than like what it's supposed to be. You understand what I'm saying? For instance. So they're set to be proportional. So okay, all right. So what are we comparing here? Because remember in the past we've been like, for example, like last week, right? We would compare like, the US dollar to Japanese yen, for instance. So what are the things we're comparing here? What do you think? Yeah, you're comparing the length and the width of the original picture, right? That's one way to do it. So I'm comparing the length with the width here. So okay, what's the old one? I'll color code it for you, okay? So the old one would be something like, okay, well, if the old length is 6 and the width is 4 and the new width is 8, then how long is the new length? Does that make sense? Okay, so in other words, what you have here is this. You have length, 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 width, width, and width. Does that make sense? Alright, so okay, let's solve for it then. So let's say, okay, alright, so we gotta multiply these two, right? Nothing new, hopefully. 6 times 8 is 48. And then 4 times what? Right? 4x. 4 times what gives you 48? 4 times what gives you 48? Do you guys know? Right, you divide both sides by 4, or you divide 48 by 4, that would be 12. So the new size here would be 12 inches. Okay, does that make sense? Now, if this is good enough, that's good enough. I'm going to show you a different way of doing this. Okay, are you ready? So, let's say, alright, you tell me, hey, mister, that the truck is really bothering me actually. I'm not happy. Okay, alright, so let's say you go like, Mr. Ring, could I just compare the length to the width of the picture? So for instance, this is what I mean. Okay, or the length of the length actually, and the width of the width. You can say, Mr. Ring, like, can I just compare this to this, the 6 to the 4, like this, right? Can I do 6 over 4, alright, versus what over 8? Right? You can do that too, actually. So watch this. What's 6 times 8? Yeah, 48, right? What's 4 times? So in other words, 4 times what gives you 48? Oh, it's 12 again. The answer doesn't change, in other words. That's what I'm trying to say. Okay? Alright? Let's move on. So, okay, let's try one of these together. Okay? Because the questions aren't hard. Okay, let's see. An original online image has been resized. In the original image, the dimensions were 5 inches in width. So let's say this is the original. Okay? Oh, so again, write down these two rectangles. Okay? Alright, you ready? So the original is 5. 5 is the short side, right? Because it says so. 7 is the long side. Alright, if the new image is 6 inches in width, what is this one now? How long is this? You good? Okay, alright, so let's set it up. Alright, so everyone follow along. Alright, so again, we're doing length, right, to width. Length is 7, to the width is 5. By the way, here's what you can't do. Okay, I'll use red. You can't go like this is the length, and then you're gonna use this width. Like, that's nonsensical, right? They're not even from the same rectangle. So you can't do that. Okay, you understand? So, okay, alright, so let's see. 7 to 5, right? So 7 to 5, and then length to 6. By the way, if you want to do width to length, you can do that too. Like, everything just gonna get flipped upside down. So you have width, length, width, length. It'll be the same answer. Okay? So don't worry about that. Now, here, let's do some math. 7 times 6 is what? 42, right? 5 times what gives you 42? Uh-oh. Does anyone know? Alright. What is it? You can use your calculator. Alright? Okay, do it in your head. 5 going to 42 how many times? Yeah, 8 times, right? What's left over? Alright, let's just do it here. Alright, 5 going to 42, 8 times. 8, 5 is 40. I'm left with 2. So 8 going to, I add a decimal here, right? So 5 going to 20 how many times? Yeah, 4 times. 8.4. 8.4 what? Oh wait, oops. Inches. Just like that. Okay, if you don't understand, you could just rewind and watch it again. Okay, one more example. Okay, is that it? Okay, yeah. Alright, one more example. Jack was planting a tree. He was to, alright, he's trying to get a hole that's 3 feet deep. Okay, so now I'm gonna tell you now, if you see questions like these, you should draw it out. Okay, you got that? So we got a tree here, that's my tree. Alright. So don't laugh, okay? Art is not my talent. So he was to, alright, there's a tree, okay, so there's a hole, alright. Is there brown? Okay, perfect. Alright, so he's gonna do a hole like that, right? That's 3 feet deep. Alright, so 3 feet deep. Wait, what? Hold on, let me think real quick. For every 5, okay, alright, okay, got it. Okay, alright, something like this. Okay, it's not a great representation what I'm about to do. Okay, but I think you will understand why I'm doing that. Okay, so if a tree is 5 feet in height, this thing will be 3. How about that? Oh my god, the truck. Alright. Okay, does that make sense? So now he's gonna got a huge tree. Okay, that will reach all the way up to the sky. Alright, so let's draw a big tree. It's about to get worse. Okay, so this is 17 feet high. So how deep, alright, I should draw a bigger hole actually. Okay, how deep would this be? You understand? Does that make sense? So, okay, let's have a proportion. Now, what are we comparing here? Right? We're comparing how deep something is, depth. Alright, this is how you spell depth. Not D-E-A-T-H, depth. Alright, and height. That's what we're comparing. You got that? So you're always looking for the unit. You understand? Right? I'm comparing the depth with the height. So, okay, let's set it up. 3 feet deep for every 5 feet in height. So, okay, if it's 17 feet high, where does the 17 go? Up there or below? Yeah, below, right? So height is at the bottom, so that goes up there. Is that clear? Okay, alright. So let's do some math. 3 times 17, what's 3 times 17? Alright, 3 7 21, you should know. Yep, 51. 5 times x is 5x, right? 5 times what gives you 51? Do you guys know? You can do it on your calculator. Alright, 5 going to 51 10 times. So that's 1 decimal, add a 0, 5 times 2 is 10, 10.2. So our answer is, the depth is 10.2 feet. Like that. Okay? Alright? Okay, I hope by the time we do the next video, the truck won't be there anymore. Okay, alright, so right now, alright, with the time left for the period, go on Google Classroom. There's a worksheet waiting for you. Alright, it's really straightforward. Like, I might even say it's easy. But in the back page, on the second page, there are questions with money, and there are questions with the kind of questions that we did today. Okay, so, and then the answer key also comes with, online from that same document. So, okay, alright, I think I'm done for today. Thanks for watching, and I will talk to you guys again tomorrow for Tuesday. Okay, alright, have a good day. Bye now. OMG, that was so good.